afternoon, everyone. Thank you, ma'am. Forwarding the discussion to the live simulation, I would like to launch the NetSim. This is the NetSim home screen. And to create a simple network or a new network, go to the simulation and just open the new and then enter networks to create a very simple network. Network as we have seen previously. So this is the node wide nodes. So I'll just select the wide nodes and drop it in one server and one client. And these two are connected by an internal router. So I'll just drop the router. And these two are connected via P2P links. So I just select the link and select the wired link. Now connect it from the wide node A to the router, and from the router to the wide node B. So I just configure the device properties. So right click on the wide node A, and just click the properties. So for our convenience, we will name it as a server. And at the transport layer, as we are seeing in FTP throughput, we'll just uncheck the UDP. And at the network layer, it's an IPv4 addressing, and this is the Ethernet properties. So just accept the properties of the server. So here you can see the server, and the same configuration at the wide node 2. So for our convenience, just click it as a client, name it as a client. And then as we are seeking the FTP throughput at the wide node B, as this is a client, we will just enable Wireshark on the wide node B, that is the client. And at the transport layer, it's only the TCP new Reno, so uncheck the UDP and just accept the default properties of all the other layers. And coming to the router, it's just at the transport layer, you just need to uncheck the UDP and just accept it. And coming to this is the assuming it as a WAN link. We will configure the WAN link properties. And here, as we have seen the screenshot of the scenario, this will be a 10 Mbps with 10,000 microseconds of delay, which is 10 milliseconds. This is the 10,000 microseconds, which is 10 milliseconds delay. Accepting it, and this is assuming as a LAN link. Just configuring it at 100 Mbps and the 2 microseconds delay. So accept the properties. Now the whole network is configured. There is one left, that is an application. So here click on the application and drop it. So we need to configure even the application. As we are seeking an FTP throughput, so select the FTP. And this is actually from the server to client downlink. So select the source ID as 1 and the destination ID as 2, and select the application ending time as 3 seconds and inter-arrival time as 2 seconds, and just accept the default properties. So you can see a line which is a downlink FTP, and here these are the packet trace, event trace, and the dynamic metrics where you will analyze the results. So we'll just enable all these metrics. So it's an enable option, so just click OK. A similar way for the event trace, it's already enabled, so OK. And then the dynamic metrics for getting the plots, click OK. So now the whole network is configured, and thing is we need to run the simulation by clicking this icon. And we are simulating it only for the 4 seconds. And we are also recording the animation to visualize the packet flow. So yes, when we click OK, the NetSim execution starts. As we have enabled Wireshark, the Wireshark command is getting executed. So all the packets will be logged into this Wireshark. We go back to the simulation. So once the Wireshark starts to load, all the simulation, the total network simulation will be done. Yes. So all the throughput links, every plot is being written. So now the NetSim window will be converting into a packet animator window where we can visualize the packet flow. And the simulation, the results dashboard is just loading. So if we go to this NetSim packet animator, I'm decreasing the animation speed so that we can visualize the packet flow conveniently. Displaying. Just increasing the size to visualize a very clear packets. So TCP SIM is being sent from the server to router C, and router C is forwarding it to the client, and client is sending a TCP ACK to router C, and the router C will forward the TCP SIM ACK. And now the application traffic flows. As it is a TCP, so it will, the acknowledgements will be flowing from client to server. If we forward it to the results dashboard, we are more interested, as we are interested to see the throughput. So the throughput is 0.2 Mbps, and here we can see the average delay. So this is the simple experiment, and this experiment can be saved by clicking here. As in some example, I'm just saving the example, the total experiment. So the experiment is saved.
Thanks, Krishna. This is Venkatesh Ramayan again. So that was a quick introduction to a simple experiment. We designed the network, we configured the parameters of network and link, we enabled traces, and we ran a simulation. We saw the simulation of an animator, and then we also saw the basic results on the results dashboard. Getting into some of the details, the common measures that are usually reported in the simulator and popular in networks is the average throughput, usually defined as the total payload delivered to the destination, if it is in bytes multiplied by 8 divided by the simulation time, which is in bits per seconds, and average delay, the sum of the delay of the successfully delivered packets divided by the number of successfully delivered packets. Throughput and delay are known to be fundamental for measures of performance for voice, video, best-effort traffic, or transactions, etc. We would like to note here that these measures can be done at different layers. For example, the throughput can be measured at the application layer, at the transport layer, at the IP layer, etc. And the overheads associated with the different layers may also be computed. So you must be careful about the numbers and how you use them. The other measures that are reported or that can be computed using the simulators are jitter, useful for voice, receive signal strength indicators, retransmission counts, collision probability, etc. In this presentation, we are going to look at simple measures like throughput and delay, but we would like to comment that advanced measures are indeed possible. We can indeed compute these advanced measures also using the various files, simulation output files. So our simple introduction restricted to a simple file transfer protocol, but NetSim has an extensive libraries which supports a number of networks and protocols from at an application layer from FTP, HTTP, email, voice, and even custom traffic. At the transport layer, many versions of TCP and UDP. At the network layer, different routing protocols, including support for MANETs, IPv4 addressing. At the MAC layer, we have support for cellular networks, we have support for wireless LANs, local LANs, cognitive radios, dynamic TDMA networks, legacy networks, including queuing and scheduling policies like FIFO, WFK, and priority. Those who have worked with networks would realize or appreciate the use of the different availability of different scheduling policies in the nodes. In addition, the libraries have support for channel and propagation models and mobility models that are critical to do any large experiments. All these results, as mentioned by Mr. Krishna earlier, this metrics, packet trace, event trace, all these results are available in file formats: metrics.xml, packet trace.csv, event trace.csv, animation.txt, and even TCAP files. These files can be analyzed. For example, the results dashboard outputs results from the metrics.xml. The animation.txt can be visualized using the NetSim packet animator. The event traces can be analyzed using pivot tables. Packet traces can be analyzed by pivot tables, and Wireshark can be used to study the TCAP files. In addition, NetSim permits analytics of multiple experiments as well. So you have the simulation output saved as files across multiple experiments. NetSim permits you to analyze the multiple experiments and understand the configuration parameters. Let's go through the various files. The metrics file first. The simulator reports metrics from the simulation for network, for link, queue metrics, device metrics, protocol metrics, and application metrics. This is just a small list or a important list of items that are reported. For example, if you look at a network metric, you get a report of the data and control packets that were transmitted, received, that were in error, payloads and overheads. At a queue level, you look at the count of packets that were queued, dequeued, the number of packets that were dropped. At a device level, you have ARP tables and information on IP forwarding tables. At a protocol metric, you will have information of number of TCP segments that are transmitted, ACKs received, the number of retransmissions, and at application layers, you have metrics like throughput and delay. These results are reported in the results dashboard, either as data, like here, or as plots, like here. We had already seen the results dashboard during our simple demo, where we saw the inputs as numbers as well as in plots. The results are also available as packet traces. So what is a packet trace? It essentially captures the life of a packet in the network, or the path of a packet in the network. And this information is saved as a .csv file and is accessible using an Excel spreadsheet. So, trace of a packet. The items listed in the packet trace are, to begin with, the packet ID, the packet type. The type could be data packet, management packet, control packet, and even subtypes. The source ID and destination ID of the packet, the source and the destination, origin and the destination. The transmitter ID and receiver ID of the packet. If it is a multi-hop transmission, then the transmitter and receiver ID could identify the link through which the packet is currently going through. In and out times in the network stack. Remember, the simulator has in stack as well as out stacks. Whenever the packets actually enters an in stack or an out stack, those moments are also captured. For example, the in and out stack at the network layer could allow us to identify the queuing delay in a stack. These data available in the form of a spreadsheet can be analyzed using pivot tables, and we can compute the common measures like throughput, delay, and even advanced measures like jitter, average, jitter. In fact, we can not only compute average values, we can even compute max values and min values. Mr. Krishna will illustrate the use of packet traces to compute average throughput in a minute. We also have event traces as output of the network simulation. The event trace, in simple words, is a record of all events in the network. For example, a packet entering in and out of a network stack is an event that is recorded. There are also events associated with protocols. For example, TCP timeouts, MAC backups, or the scheduling disciplines, etc. These are associated with protocol engines. These events are also recorded. The trace has all the events that are actually scheduled, and a quick list of the important items that are recorded are the timestamp of the event ID, the event type, the device type and ID, where the event occurs, the protocol associated with the event, a packet that is possibly associated with the event, etc. In addition, the event trace also has additional data specifically for debugging that can allow us to actually build, that will help us when we actually build protocols and libraries. The event trace is also available as a CSV format and is amenable to analysis using pivot tables, and we can compute the various metrics, packet metrics, such as throughput delay, retransmission counts, collision probability, etc. We would like to mention that the event trace is a superset of the packet trace, and if your performance is limited to packet-based analysis, you should be able to compute all the data simply from the packet trace. As the event trace captures much more data than the packet trace, it is possible that the event trace is actually a much bigger file, and it might also be taking some computational effort to make these measurements. So whether we need an event trace or whether it is sufficient to have a packet trace is a question of the performance measure that we are interested in. So I will ask Mr. Krishna to demonstrate use of pivot tables on a packet trace to make simple computations like average throughput.